This promises to be a very interesting conversation. We're going to be talking about structural engineering from a roof perspective, specifically commercial solar. And today we have in the green room Mr. Sanna from Gamcorp and Mr. Trant from Greenwood Solutions. I'm Veli. I'll be acting as a mediator, trying to curb my natural disposition to talking a leg off a chair. So we're going to probably start off, I think, with Sanna talking about the basics of what structural engineering is about in regards to these commercial roofs from a static and a dead load perspective and all the other stuff that is involved with structural engineering. Yes, Mr. Sanna, please.
Thanks, Veli. Thanks for having me again. I think it's going to be a really good conversation. The whole point of this is also I'll put an introduction to engineering as a concept, but also just let's tackle some of these kind of questions that come up on a day-to-day for Gamcorp as well, right? So overall, when we're looking at loads on buildings and specifically solar panels, there's three main components to the way we understand it. Firstly is obviously the dead load component, the weight of the panels and whatever else being distributed down to the different roof structural elements, although a very important check, less critical, because if you're walking on a roof, then the 15 kilograms per square meter a solar panel is going to put is not going to be as critical as that. So what we like to say is, provided the building is designed correctly for according to the Australian standards, then dead load's rarely the concern. What's quite critical is uplift, which is that wind component, right? When panels go on a roof, the way that transfer of wind load goes to the building can differ from the way the building was originally designed. And for that reason, checking wind and more critically high wind corner zones and pressure zones is critical to the assessment of solar. And then lastly is the actual array frame componentry itself. The aluminium extrusions that span between purlins and that they support the actual solar panel structure themselves, they need to be designed and certified for use of that specific building. Now we're pushing for a site-specific certification, but has been historically general certificates that allow for building parameters and terrain categories and wind regions that can also be used. But the whole point is that the three parts need to be checked: the dead load, the uplift, the wind, and then the actual racking component. And then more uniquely is in the mix of that is fixing, how we're actually clamping to the roof or screwing to the roof, what kind of support structure we have. That's kind of a mix between the uplift check and the array frame check, because every clamp is somewhat different and every roof sheet has a unique kind of connection method. So very high-arching, what do we do as structural engineers on assessment? They're the kind of tick boxes that we cover.
Putting pallets on a roof, right?
Yep. Big one.
Trant's been doing, it is huge, and Trant's been doing, he's done a lot of work previously at Greenwood and other companies. He's been in the industry for a long time. As the jobs get bigger and there's certain time constraints, this is when there's sometimes a decision to put fully loaded pallets, and they're getting bigger, onto roofs. So where does that fit into with this whole structural engineering side of things? What is it classed as when you put a pallet onto a roof, and what are you looking at?
Yeah, big one. It's a huge one. And the reason it's a big one is because everything that an engineer does is what was the building designed for versus how we're using it now. That's pretty much the story of the game. If we're looking at a building and we're saying, okay, it's got this amount of design loads that have been allowed for it, and now we're doing something that's going to change that or change the way the building's using it. So when we're talking about solar panels, we're talking about 15 kilograms per square meter. It's pretty light load in the scheme of things. But when we're talking about pallets, you could be talking 900 kilograms, 1 ton of load on a 1 or 2 square meter load.
Even more.
Even
you
more
do a
sometimes.
bifacial panel, you're at 1.3 ton for a pallet. It's crazy.
And when you look at that, my first question I ask is, which building has ever been designed just to take an extra 1.3 tons?
Yeah.
Off the bat, it'd be quite silly for it to allow for. Now, there are platforms and specific mechanical equipments that might have allowance for that, but typically we see solar panel guys be like, do I need to do a check for pallet load? It's like, mate, that's the biggest load this building will ever see. So, and it's not to say that it won't work. It's just to say that it has to be checked to be put in very unique positions, like supported by columns or supported by the primary structure, the load to be spread out with spreader beams, like whatever it is that we need to do to kind of help the building in that very short period of time temporarily take a load that's 10 times what it's typically allowed for.
Can I just clarify for
Please.
a second? Transit, something that I went, what? Really? I didn't realise. So you mentioned bifacial panels and being a lot heavier. And so is there really these pallets that are actually like hitting a ton?
Yeah, man.
Wow.
Absolutely.
Oh my, I didn't realise that.
Absolutely.
I do all my training on a much lighter pallet, but they were a lot older panels and non-bifacials.
Well, it's all about the more panels they can fit into a pallet, the cheaper and more efficient it is to ship.
Yeah.
We started out with 40mm frames and we're down to 30mm frames now. The glass per panel is still the same, but the amount of panels in that pallet now is 30% more.
And they're getting bigger too.
And they're getting bigger.
And one of your recent podcasts with one of your guests, I don't remember the name, is that the game is about how much they can fit in a pallet, how much they can fit in a crate. And because of that, we're seeing larger panels because it fits better in a crate, for example. But the actual application and how that's installed, the physical manhandling, let alone the weight of the thing, is a whole different ballgame. This is not being considered.
Straight away now, it's a two-man lift. No way we're picking up bifacial panels day in, day out as a single man lift. It's
Absolutely.
Gone are the days.
Absolutely. Not just the weight, the safety, all the, like, you're on a roof, you're on all these things. Yeah. From that element, I can't even fathom. But from a structural perspective, people, like you said, your training's on old stuff. People have been installing for tens of years. Like, we're not here, it's not a new thing, but these things are making it definitely a new game, right? There's extra considerations now that as an industry we've never had to consider before. When you're putting 20 kilowatts on a warehouse and you got one pallet, sure, but now we're putting megawatts on, and people want to drop 30 pallets on a roof at the same time to save on scissor lift costs. And I get it, I get the logic behind it, I get the speed, the efficiency, but hey, that building wasn't designed for it. Get it checked, get a double check, get a triple check, because if that goes wrong, the implications of a pallet going wrong, damage of roof sheet, deflection of purlins, and God forbid, but deflection of rafters, the primary beams, right? They're not things that you can easily change or make safe again. They're things that you might potentially need to rip off the sheet, change the purlins, put the sheet back on. That's a construction. That's a very heavy cost, all because you dropped in the wrong spot. And then the crazy thing is, guys, when you're looking at the construction industry, just in general, there's a whole specific niche engineering, sector called temporary engineering works. And all they do is do the engineering checks for minute things that happen on site to make things more efficient and more safe. Pallets is a huge part of temporary engineering. But in the solar industry, it's like, if I can get a crane out there and make it fit, I'll use a pallet. I'll use a crane lift. But mate, you got to take it 3 steps back. Can the building handle it? How heavy are your pallets? Where are you going to drop them? How do you spread the load? These are all considerations that typically solar guys don't really take into account.
I think it's. I mean, I'll take issue with the last bit. They do. The good ones do take.
The good ones do. Absolutely.
Take that into
Sorry, I
consideration.
should have said that. Yeah.
And Trent, for example, like if you've got this really big project, and let's say it's 2 megawatt on the roof, you know that you're going to be dropping. If you are going to go down the road of dropping pallets on the roof, it's not. They're all not going to be in one area. They're going to be put in a position where you minimise carry time, especially as it's a 2-person carry. My question is, does that play a role if you put pallets, like 5 or 6 pallets in one area that has its own load, but then you put another 5 or 6 pallets over in that area, don't they just come to, you're not treating them separately, you're treating as a combined load on the actual roof of the building? Or how do you look at that?
Yeah, it's a really interesting one. I'll say you are kind of treating it separately. And I'll tell you, the load paths of things that are on roofs go from purlins to the primary structure, which is rafters, down to the columns, down to the footing, right? So you're getting this load path that goes all the way down to the ground. For rafters, when we're loading pallets, we're not putting it on the thin 150 mil purlins. We're putting them on the primary structure, the rafters.
Definitely.
Hoping that takes it down to the column, down to the footing. So when we're looking at the effects of a pallet, we're really checking that rafter component and its connection to the column and how it'll go. We're not checking the footing, but as if to say that that's that one row of available space for a specific pallet. And then we're moving 7-8 meters to the next rafter and then checking and typically would hope to think that there's some there's there's some consistency with the rafters and the portal frames, and for that reason, once you check one, you're going to get a pretty consistent result with the other parts of the warehouse. For that, but to answer your question, Valley, as well, it can be really difficult when if you look at it globally, the global effects on a building, you could argue that there's a lot of tonnage going on the roof, but how that roof is then taking that load is very direct.
Are you taking into account the manpower around that pallet, I should say? Because, one thing's putting a ton in that one spot, but I can have 4 blokes in that one area. Like, is that something I need to take into consideration when I'm running a site? Say, hey, look, guys, we've got a pallet here, but maximum number of people at one time can only be 2.
Absolutely, and that's our typical expectation is that there's no more than 2 people next to a pallet, right? If you've got, in any case, if you've got 17 people in a square meter, or or 5 people in a square meter, there's a bit too much load per square meter. So naturally, when looking at a pallet, we're looking at that. The pallet's going to be covering a 2 square meter rate. The square meters around it have an allowable live load, which is traffic load and whatever else. So there is still allowable, but we would be only encouraging a maximum of 2 people next to the pallet.
I think that's an incredibly important point. I never thought about that. That makes perfect sense. Is that a stipulation in the documentation?
Yeah, I was about to say, I've read the pallet load documentation before, and I don't believe I've come across it strictly saying this. You get on a cool room roof, suspended cool room. The first thing you do when you walk into that roof cavity is there's a sign saying per square meter this load, and essentially don't go over it.
Again, if it was critical, it would most definitely be speculated, right? If we're putting the pallet down, it's using 99% of the usable area, then we're like, hey, wait, any additional load is going to be a concern.
Yeah,
and we'll make that
so you're getting down to that finesse of you're on the margin. FYI, guys, this is the max.
Absolutely, and we're hated for it, right? We're like, you can only put 1 pallet on this rafter, and everyone's, what the hell? How is that happening? And it's because of these little things at times. Sometimes it's literally just where you're at with the utilization of that rafter. How can we allow human traffic? Because it's all good to be able to put the pallet, but if you can't touch it, there's no good point for it. So that's the other consideration. When we're checking for an 800 kilogram pallet, we're not checking for 800 on the dot. We're allowing these additional variations, but again, it is spread as a per square meter load. It is obviously it's a larger load in that 2 square meters, but we would physically, like, we don't as and I should say this is a Gamcorp process. It's not an industry process, but we don't do a pallet assessment unless we have structure drawings, so we can do a 3D space gas model, where we've seen in the past where people have just done a very simply supported check of a beam, as if to say, and this is getting a bit technical, maybe other engineers will understand this, but there's 2 ways of checking something. It's either looking at the entirety of the thing or taking out one specific section of it. We're not risking the one specific section. We're going to check the entire portal frame. We're not going to do the pallet. We've lost a lot of work for it, but we've also been appreciated for that level of diligence as well. So this will be a contention point where someone will say, they screwed me on that one time when they couldn't check it, right? But that's the reality of how serious it is for us.
Even from my perspective, you've got to look at the whole building. You can't just say, yep, that one beam can handle it. What's it connected to?
Exactly.
We're up on that roof.
Trent, and this comes from an experience, and I'm glad you're here because I've been told and I've heard that you have that experience, but a lot of people don't understand this, right? They just look at it and say, I've seen it done on this job. The connection should be fine. But we're talking about loads that are 10 times more than allowed. And without that experience, we've seen pallets cause damage to buildings.
Yeah. What about a situation where, say, for instance, one of the Greenwood A grades goes to site and he's doing his site assessment, and it's an old building and there's no structure. They can't find them. There's no drawings. What happened? So you've got no drawings to go off with.
Yep.
What's Gamcorp's approach to a situation like that where, a train comes back, there's no drawings on that particular site, can we still put pallets on the roof?
Yeah, have this conversation once a week, Valley, and the truth of the matter is that without drawings, Gamcorp won't provide a pallet assessment.
Yeah.
It's as simple as that, right? It's the connection. We've done pallet assessments where the whole beam's fine, but then the connection in the top left corner, right where it's connected to the column, buckles. According to our model. I'm not saying it would happen in reality, but according to our model, there's a failure at the connection point. But if you guys went out there and looked at it and said, blah, 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 how are you going to tell me the weld thickness? And if it's fully penetrated butt weld, or if it's a fillet weld, how do we, you can't physically see that, right? So we say, without drawings, we might use a scissor. It's going to take you longer, but it's going to be bloody safer.
I guess taking it one step back, going, all right, pallets are off the table, but we can actually do an on-site assessment for panel loading.
Yes.
Yeah.
Because panels are 15 kilograms per square meter, and the general allowable loads for buildings, live load alone is 25 kilograms per square meter, just for you to be able to safely walk on it. So the effective weight that a panel is within the bounds of the standards. It's within the bounds of what's allowed for a load on a roof. What we're talking about here is loads that are not in the bounds of the base design level. And because it's outside of the base design level, we need to do a more elaborate check.
Can I clarify here? You're talking about acceptable weights on a roof.
Correct.
But we're not talking. Are you talking about specifically on the purlins or anywhere on the roof?
So right now, the question that Tran's posing is, why don't we need structural drawings for solar panels, as in just a panel installation, right? That is why we don't. It's because it's within the limits. But for pallets, we only say you can't put on the purlins. No purlin's been designed for a ton load.
No, I'm talking about more as in you say that the roof can take 25 kilograms per square meter.
Yes.
And that's working on the assumption that people walk around on the roof.
Yes.
But does that mean at any point on any
Correct.
part of the roof, you can
Correct.
take it? So off a purlin, off
On a
whatever,
purlin,
or on a
absolutely.
purlin, it's 25 metres. Right, okay.
And the whole point of that is even the roof sheets themselves have to be fabricated for a certain level of dead load and uplift. Even though they're technically known as architectural cladding, they have to have the structural ability to be able to span these spacings of purlins and whatever else to allow for these base loads. Or you'd have people falling through roofs, which just, obviously it has happened historically, but it doesn't generally happen because of the standards and the allowable loads of the standards.
Very interesting. It's and of course, as we mentioned before, nowadays with the systems getting bigger and bigger, recently Audits, I did a post on LinkedIn. Audits have done I think over 4 megawatt on a roof with batteries. The batteries obviously not on the roof.
Yeah.
So we're talking about a lot bigger systems, and you ain't using no domestic panel lifter to get your panels up on the roof. You are invariably, in most cases on those big jobs, you're dropping these pallets up there. So it's always been incredibly important. The other thing I'd like to talk about is that in a previous conversation you mentioned about the balancing of, on certain roof structures, the balancing of weight and loads, and how ideally, if you could, you'd like designers to design on both the, let's say, ideally, east and west facing roofs on a particular kind of roof structure. Can you explain what that roof structure is specifically?
So
without diagrams.
Yeah, without diagrams,
Sorry.
it's tricky. No. If you can visualize it, you've got two columns on the edge of a warehouse, and they've got two rafters that connect to a ridge. Right. That is something that the connection type that can be designed to be something called a portal frame. And a portal frame, although it's technically 4 separate pieces, the way it's designed is it's as if it was one piece. The connections are put in a way that if you were to deflect a certain part of that portal frame, it affects all other components of that portal frame. As if to say it's not a simply supported beam and then another simply supported beam, right? And because of that, what we found, the only time where dead load can become a problem, again, kind of crossing how the building was designed versus how it's being used now. We have solar installers, God bless them, they love a north-facing roof, right? You get the most amount of output on a north-facing roof, flush or tilt or whatever it is. And because of that, you overload one side of the portal frame, right? So you're putting all your panels, although it's a small amount in the scheme of what the building's allowed for, because of the uneven loading, you could have excessive deflection on one side of the roof where you're putting all the weight, and then an uplift potential deflection on the other side of the roof because it's all considered one beam. So it's like a triangle. When you push down one side, and if it was completely full, you'd want to pop out the other side. So that's the kind of high level review of it. And again, nothing I'm saying is that it's not going to work. Most of the times it's fine, but is that an extra consideration because the building wasn't designed like that? Hey, it's an extra hour, 2 hours of an engineer's time to do that check. Just do the check, make sure it's not a problem.
I think it's really hard from our perspective, like Greenwood's perspective, or any company installing rooftop solar, is that you can't change the orientation of the panels because the roof is the roof. It's not like ground mount where you can go, hey, I've got enough room, I can change everything 90 degrees or what have you. And what also has intrinsically changed is that now that there is virtually no feed-in tariff anywhere, and in addition, batteries are becoming very important. The ideal roof is going back to the north-facing roof. So previously, before batteries, and when there was, like a fairly decent feed-in tariff or whatever, you're looking more from a consumption load profile, But now it's actually in batteries. The fact that batteries are coming in, that you are going, ideally we're facing things north.
Yeah.
But of course, we're not going to go up on tilt if it's not cost effective. We're going to always stay FTR, flat to the roof. So there's all these things that we have to consider when we're assessing these roofs. Trent, you've got this inspection. You're looking at the roof. Are you walking onto these roofs going, I'm aware that even though we could fit 1 megawatt on this roof, that maybe the engineer is going to say no because of those roof zones? Is that something in the back of your mind when you go?
Definitely. As soon as we step foot on that roof, we're aware that regardless of what we think, that the engineer is going to come back and say that corner zone is a no-go. And depending on the size of the roof, it'll determine how big that corner zone is. And, Sanna will be able to elaborate more on the actual measurements of buildings and the zoning, but it's huge. And then even your feet spacing, the edge zone, intermediate, centre zone. Like the dream is just to have the whole roof class as a centre zone, but ultimately, half of it's going to be a centre zone, and then the other half's going to fall into different zonings and different feet requirements and spacing that goes with it.
Yeah, and this has probably only been a thing in the last, I would like to say in the last 8 years, while we've kind of educated and kind of brought attention to the concept of wind zones on roofs. Now, I shouldn't say it's a very common concept for engineers, but for the solar industry, they're unfamiliar with the fact that corner zones have a higher wind pressure zone than the internal zone historically. Now, over time, we've helped explain that according to the code, depending on the size of the building, there's a basic formula in the scheme of engineering formulas, but it's based on the breadth and the depth of the building and the ratio of that and its height. These zones appear on the roof, and the way the code explains it is that effectively in the corners you have 3 directions of wind that are going to hit that corner. Effectively, one an easterly, a southerly, and an east southerly, and how it affects the walls and how it goes onto the roof is a whole study, and it's a study that. There's a unique type of engineering just called wind engineering, and they're specialists in how these come together. Now, 2 things should be said. The code's just recently doubled that zone, so now it's 2 times on certain types of buildings when the ratio of the breadth and depth.
Sorry, Sanna, how recent is that?
2021 update.
Update
that made the mandatory in 2022.
Right.
It has doubled the zones, which is a discussion in itself, because a lot of buildings weren't designed for that increased wind pressure and now are just not working. But let's put that aside for now. The problem here is about the wind zones, is about that we understand that wind differs in different segments, and the code explains that when you're looking at a racking component, everything we're doing with racking, if we're looking at the racking in itself, it might be able to withstand these wind pressures. But when we're looking at the whole system together, about racking going down, connecting, let's say for a clamp or a screw, going down into that purlin, fixing becomes really critical, because that fixing capacity is less than what the purlin to the sheet or the purlin to the raft.
Are you looking at uplift when you're looking at that? The down, just up, isn't it?
Uplift. Now, there is unique cases where there is something called downwind, which is when the building's really, really wide, and wind can actually have an effect on a downward pressure as well. But what we're referring to is predominantly fixing being an issue and uplift being an issue for the racking to be connected to the corner of in that high wind pressure zone. The problem here is, and this is again where I should have from the very start caveated with everything I'm saying is my experience from Gamcorp. I'm sure there are plenty of engineers out there that have a really good methodology and understanding. I'm just giving my personal opinion, not factual information. But the problem here is that different engineers use different parts of the code, and the Australian code, God bless it, it's quite complex, and for the construction industry, it's amazing. But for the solar industry and the structural assessments for solar, there is like one appendix that references it properly, and even that has got some questionable things. And I'll go that's a discussion to have from engineer to engineer. But there's how you're calculating these wind pressures. The codes allow you to do these like simplified models.
Can I clarify? So you're talking codes.
Yes.
Mate, I'm stupid. Is a code a standard? And a
Yeah,
standard
sorry.
code?
A code is 1170.2.
Oh, it is.
It's an Australian standard.
Australian standard.
Yeah, well, this is probably jargon using the word codes, but codes or
Threw
standards.
me off. Yeah.
Apologies. The standards here are pretty much saying that there are simplified versions of assessing this, or there's how buildings were designed. The way we check it is against how buildings were designed. The way some people check it is based on an appendix that allows for a simplified assessment. I think that there's an inherent danger with a simplified assessment. I like to say, checking it against how buildings are designed is how that building was designed, and therefore is the most accurate check.
Well, I want to clarify, because with electrical standards, it's all really about that yin and yang, yes and no, shall and should. Are we talking about the simplified methods that are available to structural engineers? It falls under the you're allowed to do it, you shall only do it this method. You see, this is...
Yeah, no, 100%. And I'll explain it. The appendix I'm referring to is an appendix that talks about, for example, a panel that's installed flush feels a similar pressure than the building would feel. Right, and it's a very ambiguous argument. It comes from a study that was done by a university who helps develop the code, and that wind study was done on a residential style building, like effectively a rectangular house. And then they've given you the ability as an engineer to extrapolate that to make it bigger, for example, with a ratio to say that if we've tested this small thing and if it was bigger, then it would operate in a similar way. But that test was done on very unique parameters. A rectangular shape, perfectly shaped building with this ratio of breadth and depth and whatever else. What we're finding is a lot of buildings don't fall in that category. And this study was never done on a large scale. It was done on a very small scale. So there's a lot of questionable how heavily we can adopt this is a huge question. We've had meetings with the actual university who provided this study and said, do you know people are using it for L-shaped roofs? And they're like, no. Like, do you know that people think that you don't need to check because they say the pressure is the same on a flush, so you don't need to check it? They're like, no. And I'm like, can you provide us something written so we can tell the industry, hey, these are the guys who brought it up. This is not just Gamcorp spieling around. These are the guys who have brought it up, and we're having good discourse on why it's dangerous potentially to make these assumptions. So that's coming out soon. I'm really crossing my arms.
I think as an industry, solar's changed over the last 10 years. Like, we're ever evolving new technology, new products, new ways of installing. But it sounds like the standards aren't keeping up to date.
Mate, the standards in Australia, God bless, a lot of things takes a long time to do, but the focus they have is on big construction, and it's this wind code, this change in wind code for us is detrimental, but for the building designers, they're just like, okay, just change this factor and I'll design the buildings like this from now on, right? We're trying to use buildings after the fact and trying to tailor it to a non-existing standard for solar, and we're just doing it based on experience, based on seeing failures that happen on roofs and saying, why did that failure occur? Looking into it, having discussions with the like of the best wind specialists in Australia and saying, what are your thoughts? And then coming together and saying, hey, it's because it's got higher wind pressures on it. Trent, there was a year, I'll tell you now, 2019 or 18, I told someone they needed 3 rails. And they were like, no way, you bloody conservative bastard. 3 rails, they increased my cost, blah, 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 blah. Mate, 2025, how common is 3 rails? Yeah, 4 rails is common, right? But there was a time that even that was considered.
Steady on, 4 rails.
Yeah, in corner zones. But the point I'm making is like, that was known to be considerably conservative, and other engineers are like, yeah, we've checked the dead load, go ahead and install. We're like, how about wind? Like, is this not even a consideration that we're having right now? The point I'm making is that was conservative. Now it's like, but I got to put 4 rails. That's conservative. And in a few years' time, Val, you'll say, steady down, man, 6 rails. That's does that make sense?
You're saying extra rails. In my mind, why can't I just put extra feet?
Yeah.
Why not? Instead of going 3 rails, I'll just put 1 extra foot in.
I think we'll hold on to that one, because
that's a good one. That's a good one.
It's an interesting area in its own right. But I wanted to ask a question. because I'm listening to you guys talk
Yeah.
and learning, always learning. Now, is there any difference between systems from an upload perspective? If you're running let's say you're running the one option, the majority option in commercial solar, running the rail perpendicular to the purlin, so landscape all the way to the gutter and all the way to the peak, right? And the old way or the domestic way, but it's on commercial, is you're running parallel to the purlin. Let's assume the fixings are correct on both. I reckon the wind loading on one is more than the other, because with the rail running perpendicular to the purlin, you got the wind coming up the rail unimpeded all the way from the gutter, going all the way up to the ridge. Whereas if you've got the rail parallel to the purlin, you've got the wind hitting that rail and then going up and over and bang and bang. Now, is there any consideration made between those two methods of installation?
So it's a fair point. The code talks about the effect of, we're talking flat to roof, by the way. We're talking
FTR,
flush, right?
yeah, flat to roof.
The code says that the actual gap between the panel and the roof and its effect on uplift there is an extra consideration, but it's also kind of cancels itself out. And I say this because it's confusing, but at a maximum wind event, what we're checking for isn't your day-to-day wind, right? We're talking about a 1 in 200 year storm or a 1 in 500 year storm. Hopefully in our lifetime, these storms never happen, for the safety of everyone around us, let alone for the solar panels on the roof, for everyone's safety. But when we're looking at that type of wind pressure, that's not the major consideration.
Right.
When looking at the sheeting holding onto the purlins, the structure not tipping over, there's a lot of extra considerations and the concern around if the rails create what we would like to call a shielding factor to the wind pressure on the panel. And the other statement is, when we're looking at these wind pressures, although we're looking at one direction of wind, you were talking about the direction of wind that goes up the sheet.
Correct.
But we're checking 8 directions of
Yeah,
wind,
good
right? We're
point.
checking every critical, if the critical direction of wind is this point, it'll have a different effect to if the wind was this point.
Very
We're
good
checking
point.
all of them. The last thing I'll say is this becomes a very critical discussion around perpendicular and parallel when you're doing tilts. When you're doing tilts, if your critical wind direction is in the direction that's going effectively sideways along the panels, as opposed to behind the panel or in front of the panel, that can make a difference.
Wow.
Absolutely.
Wow.
Because it works like a kite in a sense. But flat to roof, we're looking at worst case, every direction. And in that case, it's shielding of the rails to the gap is not going to be a make or break.
But there's prevailing winds on every geographical location, isn't
Absolutely.
there? So, and is that? But it's more you're looking at worst case scenario of the winds going in all directions. Okay.
Well, it's not
Very-
it's not all going at all directions at all times.
No, I know.
But we're just checking every
Yeah,
direction
every
critically.
direction. I think something. I stopped Trant from progressing with the number of feet question. Let's go to that. Because I think this is really important. And Trant, can you ask that question again about, well, instead of an extra rail, why don't we whack in more feet?
Yeah, definitely. So, you see 3 or 4 rail systems and we're on the roof, and especially if it's clip lock, I can just put a foot wherever I want to put a foot. So I don't know, I guess it's a valid point, and I'm always been interested to find that the true answer is, why can't I just throw in extra feet to overcome that uplift pressure?
Yeah, so there's two discussions here. The first one is the concept of off-Purlin installation, as if to say that your clamp is connected to a roof sheet, but not over the area where the purlin is located. Right, that's the first discussion. The second discussion is, how many clamps do we need to counteract the wind pressure? Right, so there are 2 things. I will say that second part is easier to explain and general engineering principle, but the first part, off-Purlin, is really, really critical, right? And again, the caveat, not just Gamcorp, but there are a few engineers within Australia that understand this and apply this, but there are also engineers in Australia that I have a great amount of respect for, and some that I maybe don't have a lot of amount of respect for, that agree with off-Purlin, but they too have their own unique methodologies. Some of them I can understand and appreciate, others I can't understand and appreciate at all. The Gamcorp methodology is a best practice methodology. It's to say that we've seen things happen historically. We've seen failures. We've done a lot of testing ourselves, and we've reviewed a lot of testing ourselves. And with all these examples of failures, testing, talking to roof sheet manufacturers ourselves and getting their guidance from their products. It's not our products. It's Lysats, it's Stramets, it's Metrolls, whoever it is, and saying, what do you guys think about this? How your roof sheets are being used? So going on the off-Purlin discussion, there's one main point. The first point is that a roof sheeting around the world is different. In Germany, in America, in certain countries, the way they construct a roof, even if they use purlins, is that they have these, very commonly, have these plywood systems or other types of rigid systems between or on top of the purlins. And that's because they have snow load considerations, they have unique wind load considerations, and for that it's become standard practice for them to use these quite thickened or more rigid roofing structures. In Australia, we're like lean and clean. Like you go purlins and then straight away we've got these sheets that have these ribs, like clip lock ribs and whatever else, that give the sheet the ability to span between purlins. And depending on, there's some like king span insulated sheets, they can span even longer, which is great because they reduce construction time, all this stuff. But then how do this stuff, now that we don't have this plywood or this potentially insulated sheet, we're relying on a 0.42 millimeter sheeting that spans, call it 1.2 meters between purlins. Now, at the point of how these are constructed, there's a clip that sits on the purlin, and the sheet is literally by foot or just by pressure pushed down into this clip, right? Not a complex system. It's governed by this clip's ability with friction to cling on to these little tiny clip lock ribs. Now we've done 1,000 tests, maybe more, done and seen 1,000 tests where we're looking at how the sheet disengages, and it's got nothing to do with the purlin. It's got to do with this clip and this sheet detaching. So all we know is that the product's been designed to have this clip attached to this sheet, and if you put a clamp over the top of it, it can actually support it. It can make it potentially even stronger, right? Because you're gripping that sheet even more so over that clip.
So we're talking here, obviously, all non-penetrative approaches.
We're talking about clip locks. So these are clip locks. The point we make is that when you're on purlin, it makes perfect sense. Your foot is over the clip, over the sheet, and when it hits an upfoot force, we've tested that thing so many times, and we know the capacity of that.
You're not worried about the sheet itself holding the weight, because if I put a clip lock in the center, you're not worried about that weight transfer. You're worried about the clip itself.
That's what
coming
we're
loose.
The clip, that bloody little clip, is the main point. Now, the first thing should be said. Different clips are different. We have some clips, and I don't want to mention the actual manufacturers because it could be, but the range is from 0.8 kilonewtons force to 2.6. So there's certain clips that are 3-4 times stronger than other clips.
Yeah.
We're looking at standing seam roof sheets, like the long line sheets, the really thin sheets. And that's, forget about the clip, you're using a piece of rubber to hold on to that. Like, what's the pressure of the rubber? And if people can't just use their brains and realize, hey, there's probably a bit of a difference here, then there's a problem, right? And we're here to say they've got different capacities. You need 3 rails on this one, and you need 2 rails on this one because this one's stronger and this one's weaker. Now, that's talking about clamps, on clips, on sheets.
Yeah.
But then, in recent times, and even in the past, I'll be the first to admit, 2017, Gamcorp certified Off-Purlin, and we did for a long period of time. But again, with experience and with understanding best practice and looking at testing and talking to wind specialists and et cetera, we've come to a point where we've said there are cases where failures have occurred historically because you've got, and work with me here because I don't have a diagram to show here, but you've got a clip, you've got a sheet on a rib that's on a purlin, and then you've got, it spans a certain distance, and you've got another clip on a purlin, right? What people are saying is, I can just put a clamp here, a clamp here, a clamp here, and a clamp here, then I have 10 times the amount of fixing. But
practically speaking, that's what I'm saying.
But now work with me here. Wind hits the panel, okay? It wants, the panel and the rails want to go up. Right? That's just natural. Wind hits a panel, the panel wants to go up. What happens? You got 2 clamps that are rigid. They can't move. Yeah. They're on the purlin. They're not going to go up and down. Unless the whole purlins go up and down, they're pretty bloody rigid. And then you got these middle clamps in the middle that are being supported by 0.42 millimeter roof sheet. What do they want to do? They want to go up and down. It's a flexible panel. It's a flexible sheet that's not designed to be rigid. So what's happening? You got these guys that are holding it down, and these guys are just not doing anything. They're just bouncing up and down. So what capacity do you give that? Yeah. We can't test for that capacity. We don't know, because it's got nothing to do with it. It's got to do with the clip. It's got to do with the purlin. So put 50 clamps under your sheeting. Put 100. Yes, you'll get some kind of capacity, but most of the heavy lifting is being done on that rigid part, and the middle clamps are just bumping up and jumping up and down. And I have less of a problem with it if people are doing on-Purlin and off-Purlin.
Yeah.
Then I'm like, yeah, you could argue that. But we've seen installations where they've done parallel to purlins, and the whole thing has been installed off-Purlin. The whole thing is bouncing up and down on an area that, and the argument is it's being supported by the purlins next to it. It's like, mate, there is no rigidity in that system. Your mid clamps are going to get loose over time because that thing is bouncing up and down, and the mid clamps bolts bloody trying to hold on and get loosened over time, and then you see panels dislodge. And then people say, "Why on Purlin?" I'm like, but it's a valid question. It's a valid question because it's such a nuanced thing, and we wouldn't have even come across it unless we've seen the things that we've seen. What we're saying is, for your business and for your structural integrity and for the end client and the safety of the people that are around that building, chuck it on a Purlin and add an extra rail and everyone's safe. You're using structural bits, not architectural cladding, using structural clips on structural Purlins, transferring to structural rafters, to columns, to foundation. Put it on Purlin, put it off Purlin, your guess is as good as mine. There is a potential risk there. All the best to you. We can't support that. That's Gamcorp's position on that.
Interesting. Yeah, I didn't realise it came down to the clip and that
Mate,
holding. Essentially, your bracket is holding the clip to make it stronger.
I wouldn't even say we don't even care if it makes it stronger or not. We're testing the limitation of that clip. Now we test it with every unique clamp. So as an example, a Clip Lock Classic has been tested with Clenergy, with Sunlock, with Schledder, with all of them have tested it, and they all have slightly different results. Slightly. They're more or less the same, but one will have, let's say, 1.8, the other one will have 1.9, the other one will have 1.75, and that's only because they kind of help it differently, in a different way, depending on if it's like a ERI07 that has a long grip, or if it's a smaller, more narrow clamp that only grips it really soft, and if you're on the clip exactly. And so the point I'm trying to make is that they all have a unique strength, but that's only adds to the concept of there being a variation, there being a difference. Yeah. And you can't just have a rule of thumb to say clip lock anywhere, because it's like, well, on what justification? Now, there is one engineering company, I won't mention him by name, but he's an absolute gentleman, and he's a great engineer in Australia. And the way he's done it, he's like reversed engineered it, where he said that the roof sheet manufacturers have given results on the maximum uplift that the sheet can handle, and therefore I'm using that result and comparing it with the pressure that the panels are having and giving it off-Purlin installation. Now, that's his prerogative. He's definitely happy to do that. But what we're saying is that in reality, the loads are inconsistent. You're going to have one that's like 90% close to a Purlin, the next that's in between two Purlins, the next that's 10% off a Purlin, and when a wind pressure comes up, this racking's like, doesn't know where to get it. It's like fixed on one side, kind of fixed on the other, not fixed at all, and flex on that. So because of that inconsistency, how do you guarantee over 20 years that won't effectively loosen the mid clamps or loosen the bolt connections? You can't guarantee. I can't guarantee it. And in the construction industry, bolts, especially open to air bolts, are checked annually every couple of years. And solar industry, technically, and this is probably I should be doing their audits as well. But the reality is, how often do they do it, right? And then we see failures, and people are like, I installed it correctly with the correct torques in 2021. It's like, mate, it's been 3 years, and anything could have happened. And you're off Purlin, and it's flexing. And anyway, you can see I'm passionate about it because I've just had this conversation too many times, and it's a legit nuance. Like, it's a real tricky, fiddly one. But either way, I hope that answered your question.
Yeah, it definitely did. Yeah.
We kind of joked about this before we started, and we're like, I'll tackle it when we get into the chat. So I'm glad that we got to hash it out either way.
All right, well, I'll throw another spanner in the works, and this is only because I saw something up at Queensland recently at the Smart Energy Convention. And this is a system of mounting panels that doesn't use rail, right? It's an American system. It's been around a while, and they're trying to push it. So you're talking about a railless system. How the heck... I mean, obviously the rail from a structural point is it tied in with the feet. How the heck would these systems go from a structural engineer going, well, You can do it, but you got a lot of restrictions. Is that the scenario? Because they've got no rail.
Again, got to be careful with how I say this. And there's not just one. There's many. There's many in the market right now that are railless systems.
Right.
And there's some that do it really well. Again, this is Gamcorp's viewpoint. This is nothing related to the business. We want nothing but success. And for us, it would be a bloody dream if we could have a railless system and certify it everywhere, because it would solve a lot of our internal problems and the challenges that we have on many, many, many projects. What I would like to say is that the products have been tested really well. They all have gone through excessive wind tunnel tests to make sure that the product is suitable. Our concern is not the product itself. I think the products are great. They're great. They've been tested. They can provide that assurance. All we're saying is, how does it play with the building, and get that checked. That's all we're saying. And if you can justify it with the checks of the building, then go for it. But we've certified potentially like what we would consider potentially a railless system on certain types of sheets, right? When you have kingspan sheet or insulated sheets, absolutely you can get away with those types of systems, because the sheet itself has a structural limitation. It has consideration for structural loads, both uplift, dead load, everything. But on a lot of these types of sheets, we've talked to the manufacturers of the sheets, and they're like, this is an architectural cladding. Get the hell off our sheets. Like you can't use our sheet as a structural tool. It's not warranted. It's not tested. It's not certified for it to be other than dispersing water and human trafficking. Like, so you walking on the trafficking the roof, and the water dispelling snow and water and hail to the gutters and what. That's what it's been designed for. Now we're putting random, what we call incongruent loads, like random loads at different spots, and making it work. If there are purlins that have been designed and you're within like, this is an arbitrary number, but if you're within a 50 or 100 mil of the purlin and you can make that system work, go for your life. Right? We're not here to stop you, but if you're going to get me to check a building and its purlin spacings are 1.6 meters and you're connecting these things effectively entirely off purlin, my only statement is, over a 20-year period, do them elements get loose? Can you guarantee that the flex that will naturally happen consistently hold that? And if you can, go for it.
Are you talking about specifically the railless systems or all systems?
I would say all systems, but including the railless systems.
The way I see the railless systems, you can only really install the panels in a portrait configuration, a la the opposite way of most commercial solar systems, and then obviously the clamps would be on the purlins, assuming 1.2, 1.4, take into consideration a 2 metre or 2.2 metre, whatever the length of panel you're using. But you wouldn't be able to turn them around like that and run them down like what we tend to do and most people do. I'm only interested from the perspective of how much time it would save the guys if they did do that.
Absolutely.
But of course, we're here to talk structural stuff. So
Again, I just want to make it clear. It's not that we're like, these systems don't work and blah blah blah. They're used for different roofs. It's not that. It's to say that, and this is in every case with every racking manufacturer, railless or rails. Their job is to make sure that their products are suitable, tested, and suitable for Australia's application. And they've done that. And they're great. And there's some that haven't, but you should be using the ones that have, right? But then the next part is, how does that system adversely affect the building? And if it doesn't, go for it. But there is a stipulation in the code, the standard AS 5033, which is the solar standard, that says that the two elements to this. The first is that everything you use has to be suitable for Australia's use, right? That's a pretty common statement. And the second one is that as a solar installer, you have to ensure that it doesn't adversely affect the building. Now, with complete respect, there's great experience that can have that, but how does any solar installer guarantee that they're not adversely affecting the building? With respect, that's not a call a solar installer can make. It's not their prerogative. It's not their scope. It's not their experience. Their experience should be where it is, and you should be getting guidance, not from Gamcorp, but from any structural engineer to say, am I good or am I not good? And then you can wholeheartedly say, according to 5033, I've done my due diligence. My racking is up to date. My building is, my client's not going to be affected by this. Let's go ahead and install.
Well, this is the issue, isn't it? Like, you're offering the client a financial proposal. They can, spend more on marketing, buy more machinery, spend more on people. They can go down the road of a commercial solar system. you've gone in there and you've offered them 1 meg because you go, hey, I don't have the guidelines, I don't know, covering the roof, and suddenly comes back, no, you can only fix 600. Suddenly you've got egg in your face. Suddenly the whole financial proposition changes. So we as an industry, we have to know this stuff before we get to site, don't we?
There's huge pressure on it though. You get the salesman goes out to site and they'll sell a system and sell the world to them, and then we get to site and we're interpreting the structural drawing or engineering that you've provided, and we're looking at it and going, no way can we fit all these panels on this roof.
But hear me out. We have a training for sales teams for this reason. We have calculators that let them calculate what these zones are going to look. The way I've been dealing with solar installs historically is stop giving your clients, like your building owners, proposals saying, I'm going to fill up your roof. Mate, we're past that. Right? We're just past that. And if you are, don't quote it with 2 rails across the whole roof, because we're past that as well, right?
Yeah.
Like we understand wind, we understand rail requirements, we understand more feet. For that reason, let's just be more educated on how we sell. So what we do is we provide a calculator, other people have as well, where you can put the building dimensions in, which you can pretty much get through Nearmap or Google Maps or whatever it is, and says the corner zones are going to be 3 meters. Then you say, I can give you this much guarantee. The internal zone, I could probably guarantee that we'll get this on. And then the rest of the stuff is question mark, pending engineering. And the person who's having that conversation with the building owner, telling them that we have engineering partners, this is what we see has got the least impact to your building, this is going to has to be custom checked and certified. Other people, and then the next guy goes up to him and says, I can fill up the entire roof, don't worry about engineering. Which one do you think the builder's going to go with? It's the one that actually has educated them, guided them, talked to them about the risks, the concerns, and how much their partnerships and their experience can overcome these issues. That's the piece where the difference between solar installers that have come from resi to commercial and the people that are in commercial and they're treating their customers like a commercial client, in my perspective, that's a complete difference. They're having the conversation, they're educating, they're guiding, they're telling them, don't trust someone who says, give you a full roof, because wind's a consideration, and you've got a clip block roof, and it's a blah, blah, blah. And then that becomes, who am I going to use? I'm going to use that guy. And there's some people that are always going to go out there and they're going to buy the cheap car, right? I don't know about me. I like to work with everyone that buys, for example, like I'm just talking like a good engine, right? That's I want to work with businesses. I believe that our business is a good engine. I want to work with businesses that have good engines. If someone's coming in with a I don't know, a go-kart, I'm like, you do your go-karting ways. Go for it. If I'm not competing against you, go for it. The same way I would never compare Greenwood with a resi installer who's doing commercial jobs. Like, God bless them. There's obviously different businesses and different time frames. I'm not disrespecting anyone here, but you guys are just a different beast. You have different protocols. You have different QAs. You have different experience. And because of that, there's an element of trust that an end client should know that unfortunately maybe they don't at times.
But we're still learning as well.
Of course, everyone's learning.
That's the
absolutely.
thing. So it's like having these kind of discussions is where, and hopefully the people who watch this three-way discussion will learn, because I'm certainly learning, as I'm sitting here. I want to clarify one thing though.
Please.
You're talking about the edge zone, right? And you're talking about using 3 rails.
Yes.
Or 4 in some cases. But that would only be if the rail was perpendicular to the purlin. Surely if you're up, because obviously if you're going parallel to the purlin, all you'd have to do is increase the frequency of how many feet you've got. In other words, from going from a metre apart, you'd go down to 600. Absolutely. And you wouldn't need an extra rail. So maybe for the people out there who do want to flood the roof, maybe they look at 1 total parallel to the purlin rail configurations, or depending on the aesthetics, a combination of perpendicular to the purlin and parallel to the purlin in the areas that need it, and that way you get away without using extra rail.
You're getting into some pretty high level it's a bloody awesome point, right? When you're going parallel to the rail, you're correct. All you do is increase the number of fixings and the spacings of the fixings. If I told you that you needed a fixing every 200 mil, you'd probably slap me in the back of the head. But the point is that it's possible if fixing was the problem. If the problem was fixing uplift, then we can add more fixing going parallel. Yes. The problem we have, Valley, it's not all the time about fixing. Sometimes we have buildings that have been designed by code some time ago, and now we're checking them against the current code. We have to check them against the current code. And because we have to check against the current code, not only is the wind pressure that we're checking against changed, but also it's been designed for a different wind pressure, so the building technically fails. It's not that the building's failing. It's just according to the current code and the way we have to check it now, and the change of, for example, how the rails are interacting with the purlins, it now looks like the building's failed, and that's because of the change in standards and the change in codes. Right. So what I would like to say is, and just to clarify that, as much as I say, yes, if fixing capacity is the concern, you go parallel, you increase the number of fixing. But if we're saying that the building is showing excessive deflection according to the standards, that's irrespective of the number of plans. This is saying that it's the code is saying that this building is technically under designed. But it's not that it's under designed, it's just that these changes as evolution of the standards has now made it more stringent.
And we have to not forget that these buildings were never designed to have anything on top of them apart from the bloody sheets.
Exactly. And yeah, so then there's other discussions on that. But yeah, the whole point is that know that as much as that's a really great solution, and question me on it and question Gamcorp on it, can I go parallel? Is fixing the limitation. I'm happy to put a bloody foot down every 300 mil. I couldn't care less. Give me whatever. We can have that check. We can do that check and get
what we have to do from a project perspective, though, is do the analysis on, yes, if we do use extra feet, not only is there an extra cost there compared to extra rail, but also the labour. If the labour is the most expensive thing, and of course the fatigue of the people on site doing this repetitive task. Tran, I want to ask you a question. How often do you see, and do we design in your previous jobs at different companies, inverter stations, big inverter stations on the roof? And how does that, how does that work from a structural engineering perspective as well?
As soon as I come across an inverter station on the roof, it's a big question mark, because we understand from going back to the pallet load assessment is, we know now that we need to get an engineer involved to assess that load point and whether that roof can handle it, and an inverter station's nonetheless. So you wouldn't see me building a 400 kilowatt inverter station on a roof without getting it assessed. If I'm down on the ground and I'm throwing some inverters on a precast concrete wall, well, so be it. But yeah, definitely on a roof, I'd be bringing Gamcorp in to assess it and even design the whole structure.
Yeah, and it's a real critical one, right? Like there's two things with this that we like to say from an inverter station point of view. The weight is one thing, and how you distribute that weight, but also you've got like this freestanding Unistrut or whatever it is system that wants to have a go, right? So the whole point is that whether it needs its own roof, it changes the numbers. Whether it needs how many columns, how are they supported by the roof structure, these are all real critical questions. We like to tell people, mate, I don't care how much cable it costs you, go down to that concrete wall that you were saying before, right? Because get off the roof, because it's such an extra element of risk and check and loosening and all these things that you have to guarantee for 20 years, right? And for that reason, not just that, but we're talking about electrical components. We're talking about the risk, the other related risks of fire and whatever else, if there's deflections and if there's failures. For that reason, my point is that it's definitely critical to get it checked, even if someone has a what's it called, like off-the-shelf product kit to put these things up, which is great, but then how does that interact with that building, with the wind pressures of that building, and how is it connected? These are all questions that what I'm asking people is just ask the questions. Has this been certified for all roof applications? How do I connect it to Purlin? And then you'll get the answer. We have no responsibility. Go to an engineer, right? And then you'll come and chat with us. But the point I'm making is that just know where your liability stands. Yeah. Know who's covering.
Ultimately, if we could go to the ground, we would. We're ending up on the roof because of client restraints or space restraints downstairs, and the client's just not willing to give us that internal space. So ultimately, we're on the roof and we're coming to you because day in, day out for O&M maintenance reasons, we'd much rather be on the ground.
And we're trying to encourage racking manufacturers to come up with like low hanging kind of supporting structures as opposed to really tall and standing supporting structures. And there's a lot of really innovative solar installers out there who are creating their own like combinations of A-frame kind of systems that support inverters that are allowed to be supported at a certain angle. They'll kind of makeshift their own little system. Good on them. I would say as much as you can, try and get it nice and low. Try and connect to for example, a plant of some sort if there is a plant on the roof. Even if you're somewhat just getting supported by the plant at a small amount to stop it from rotating for wind, but it's off the plant, is better than it just be freestanding at a roof segment.
Yeah.
And then lastly, when you're in shopping centers or whatever else, try and look at unique ways of areas that are shielded by different directions. Like there's at times cavities between buildings where you would say, oh, that's a good wall to at least get partial support from, or whatever it is. If you can try and
that's an interesting one you talk about shielding, because we talk about corner zones and wind zones. And sorry, I'm going back to panels now. We're going back full circle, but I see parapets 3 meters high, and we're installing in a corner zone, and the feet spacings, as you say, it's every 300 mil, but I'm installing it in front of a 2 meter high wall, and from my perspective, I'm like, surely this shouldn't be classed as a corner zone.
Yeah,
like,
absolutely.
There's a huge wind block here, but ultimately the designs come out and they've classed it as a corner zone.
So if it's 3 meters tall, then it should have some kind of shielding effect.
Yeah.
if it's 1.5 meters tall, like you up to your whatever, then potentially not. And the reason is, and this is where you go into the wind specialist avenue as opposed to the structural engineer. There are structural engineers, or were structural engineers, but they specialize in that. And the way the code explains it is that we're looking at wind in every direction, and we're looking at wind in a 1 in 200 year event. And in that event, although it shields wind from a certain direction, and then that wind would effectively dissipate and potentially, there's a code that explains even that wind that comes and hits that parapet wall creates this almost like a little bit of a warp effect in that area between the parapet wall and the edge of the roof. Now that's one element, and the other element is the wind that's coming from a diagonal from the opposite direction needs to go somewhere. And it hits this wall and hits it and still creates a corner out of the other direction. Maybe it's, if you've got a parapet wall that's like this and the wind's coming in this direction, that stops the wind from getting off the roof as well.
Yeah.
So although there is positive shielding impacts, there is also negative shielding impacts. And because of that, the way we look at it, and this is not a rule of thumb, it is checked, but the concept, after doing this so many times, you realize it kind of cancels each other out. Like there still is, but if it is 3 meters tall,
that was
a different story, right? Because it's considered like another building, and then there is shielding benefits. There is one really unique thing, and I'm going to get slammed for this in the chat for anyone that knows engineering, but shielding, when you have two buildings next to each other, is a really common thing. Like you have a building next to it, and then people say, oh, but I've got a building next to it, so why is it a blah, blah, blah? So we will say that we will take that as shielding. But some engineers say, but there's no guarantee that that building will be there for the next 20 years. And because of that, we have to consider it as potentially unshielded.
And also there's turbulence issues as well. And
Right.
and this is more applicable with wind turbine design. Funnily enough, if you don't understand, like if you're behind a wind turbine with a structure and the structure's here and the wind's this way and the turbine's there, that plays a role with how the wind actually hits the turbine.
Absolutely.
It's really weird. It's a hard one to get your head around. Wind can do some strange shit.
Absolutely.
For want of a better expression.
Yeah, no. And we have a really good, profound respect for a company in Australia that does really great work, and we constantly communication with them around these kind of nuanced kind of discussions. But the simple conversation I've had with you now is a 6-hour meeting that we've had over 1 hour segments over the last 10 years, right? It's always a discussion we're having on when can we, when can't we? Are we happy to take that risk and say, I think that building's going to be there for the next 20 years? Then we'll make that judgment call. But then someone else might say, it's old, it might not be, therefore.
Yeah, that's a valid point. That you can't take into account that it's going to be there in 20 years. And
That's why I'll get slammed, because I think it's case by case. If it's a brand new building, I think it's conservative to assume that it's not going to be there in 20 years. I think personally, that's my personal opinion, is that you can fairly assume that building that was built in 2016, which is a case that we had recently, isn't going to be there for the next 20 years because it's a beautiful building, and unless there's something really wrong with it. And if that happens, let me know, and I'll change I'll change your rails. Like that's okay, but just having that conversation and that understanding can alleviate those. I don't want to use the word conservative. It's just that understanding and how they want to apply their methodology.
yeah. And I think the other thing you've touched on a couple of times is we're talking about that 1 in 200 year event, and we're on the roof installing these systems, and the sun's out and it's balmy. We're loving it, but you got to keep in mind we're up there in the best of the best, and we've got to design these things for the worst of the worst.
I'll say two things to that. I've heard the amount of times I've heard, Belly, I've been doing this for 30 years and I've never had a panel fly off my roof. I love that statement.
Yeah, it's a grandma principle.
I love it.
My grandmother did it. I do it that way. Bullshit.
And I like to say, you've never worked with 2.3 meter long panels. You've never worked with, and you still want to do 2 rail insulation on corners, like, okay, we've never had the 1 in 200 year event. And when that happens, God forbid the people around his installations are going to be in danger, right? There's going to be, and I'm hoping in that event everyone's inside and they've barricaded their windows and and glass is covered. But realistically, do we still want panels? No, that's why the code is there. What's the standards are there. But the second point, the most important point, is we're seeing cyclones, we're seeing high wind zones happening, high wind events happening, and they're not even reaching these maximum limits. They're not getting to the design considerations that we have to design against, and we're seeing failures. Guys, it's happening. It's not happening to you, which I'm really happy about, but as a specialized engineer in the space, when something happens, we get one of the calls to come in and to look at it forensically and say, why has this happened, and provide guidance and whatever else. And when we're looking at these failures and we're providing a very easier response to some of them, a lot of the times it can be linked to workmanship, 100%, things not being done correctly, but sometimes it's because of poor engineering, and we've said it and we've had to call it out before in the past as well. And this is at wind pressures that are only hitting 80% or 85% of what the maximum wind pressure is. So it should be able to withstand that. And then when we're saying, and then they say, oh, it must be the racking. And we say, oh, well, look, we've checked the racking. The racking can withstand this level of wind pressure. And we've designed it to withstand. So it can't be the racking. But if you don't install it correctly, or if you install it with 2 rails on a corner, and if you whatever, that racking hasn't been designed for that, because it's got a limit and you have to put more racking. But people aren't aware of it. So they're using, a really common example is someone installed with a general certificate and they've said, oh, this and that. And then we're like, what bit of the table did you use? And when you get down to the cracks of it, they've used the wrong bit. The winds come only 80%, but that 80% is greater than what they've used, and panels come off the roof, right? So it's a very serious problem, and the biggest problem with all of this is that every time this happens, Gamcorp have to sign a very juicy legal NDA. That means that we can't talk shit. We can't talk about it, right? Yeah, but it's true. It's because people are worried, and rightfully they're worried about reputation, and it's not a definition of who they are as a business, one case or one thing. Yeah. But at the same time, it's a problem. We can't learn from it as industry. The funny thing is, a recent cyclone that happened in Queensland, a report came out where it said, and I'm not going to mention the name, but a third-party company. That's your favourite comment. A third-party company who's auditing the wind event has said there was no failures recorded during this event, and I just politely sent them a LinkedIn message saying, "Hey, just letting you know that pit that you wrote that there was no solar failures is factually incorrect. There's been 4, and I can show you the details of them without giving any information away. I want you not to misinform the industry." And that was the conversation that led from that. So the whole point I'm making is know that they're happening, and that we would never want it to happen to you, and we're doing everything we can for literally the safety of the people around these buildings.
Well, that just goes down to the importance of getting a site-specific engineering assessment done, because I'll read through the generic certificates, and back in the early days, we'd install off the generic certificates. But the more I'm learning, the more I've been in the industry, is you read through that certificate, and 10 years ago I'd read it, and then today I read it and go, oh geez, I missed that part. Yeah. It said the purlin thickness had to be 1.5 mil.
Yeah, huge.
Did I go check it?
Yeah.
No, I didn't.
Yeah.
I'd just gone off the generic certificate, assumed that we're all good, but another little simple one is your panel sizing. They're doing a generic certificate up to a 2 metre panel. I've just installed a 1.2 metre panel, or a 2.2 metre panel, I should say, and I've gone over the generic certificate, and I've gone over the limits that it's been designed for. So the importance of just going away and getting that site-specific assessment is huge. And for the installer coming to site, you've got faith in what you're installing is going to last, and it's going to last its lifespan being 25, 30 years, and you can go away at home and sleep and know that you're not going to get
Bloody
that
oath.
phone call and say, hey, mate, one of your panels you just flown off the roof.
Yeah, and I'll say two things to that, right? For residential, I still stand by it. For residential, general certificate is pretty okay, right? Like the wind pressure that a low-rise building feels and whatever else, it's typically okay. And the structures, especially like tile roofs and stuff, they're really robust structures for what they are, for their size. They're quite good. So I don't want to like nitpick. Like we were a part of the original committee that discuss the purpose of general certificates with Clenergy and others in the industry. And the whole point is that there is a real good purpose for them, but now we're just doing different scale things, guys. Now we're just on another level, doing millions of dollars worth of projects to rely on any person's ability to read a document that's crowded by these assumptions of purlins and panels and whatever else, and to put your business at risk to save what, $5,000 for $1 million project? I think that's
know.
you know, like
Yeah.
for me, it's like, how does it even happen, right?
yeah.
It's not like it's $500,000 to get engineering done, mate. It's under $10,000 for a megawatt project. Like in the scheme of it, what are we talking? What are we talking cost wise? It shouldn't even be a discussion.
It's a drop in the ocean.
The problem here is the engineering reports is not the $10,000 it costs. It's the fact that we'll probably educate you to tell you that you need more rails, for example, and then the cost of that, or that you can't install anywhere. And then they're like, mate, I never want to pay the 10. Don't worry about the $10,000. It's the limitations. But know that the limitations are the reason that we're engaged, just to guide you to say, in a worst case, you're covered. Sleep easy.
Yeah.
So yeah, I really appreciate the comment you made there, Trent. I think we have this training that we run, and there's a real critical point in every training I do when I mention a few red flags, where you see the eyes of the solar installer just think back to all the projects they've done and say, "Oh shit, like that makes sense," and I reckon I didn't do that, 25 times in the last. So it's a common thing.
Yeah, definitely. It's tough, and you're forever learning in the industry.
100%.
You go 10 years back, and I'm sure I've done an install that is non-compliant, just because I've missed a little bit of fine print.
Yeah, and we're all learning, and
we're learning.
as engineers in the industry, I said before, right, 2017, we were certifying Off-Purlin. Like, we've learned as well. Like, everyone has to learn. The problem I have is then new players come in the space, and they're where we were 2017. They haven't seen and they haven't dealt with the failures or the racking or the whatever else, so they'll make these arbitrary assumptions. Like a really, really important one, this for everyone should know, is that never accept a structural certificate from an engineering company that says the weight of the panels are all good, go ahead and install. Okay, that's just a blanket statement I'm going to make. The weight of the panels bloody better be okay, because the building, if it's designed correctly, should be able to take the weight. What are you even paying for? What are you paying an engineer to do there? I've seen ones where they've walked out the site, and it's on the report, it says, I've inspected the property and deemed suitable for solar. Mate, have you even done a number on that? Or are you just saying, yep, it's in good condition, if it's to the code, the weight's going to be okay? Mate, when something goes wrong, and those reports are provided, right? When something goes wrong, they just very easily say, this is the scope of my certificate. I've put the caveats that I've checked for the weight.
It's all
and
in
then
the
who's
fine print, isn't
responsible?
it? It's all in the fine print.
Who's responsible? It's a solar
see.
installer. And then they have to start going to their insurances and whatever else. But, mate, we've got to fill up the roof, and I made 30 grand extra if I went there than somewhere else. Like, this is where the conversation becomes the ingredient. This is where I say, I'll do anything to protect your business, but more importantly, I don't really care about your business. I care about the people that are in the building. I care about the actual civilization that will be potentially affected by a panel flying off the roof. We've had panels fly off the roof and smash cars. Luckily, they were in car parks and not people driving. But the point is that it's happened, and that's happened in the last 12 months, right? Like, it's a real thing, and I always joke about this, and I say this with a huge grain of salt, so I really don't take this wrong. It's very much a joke, but I really hope that one day there's a camera that 7 News or 9 News has available that sees a panel fly off and smash in the middle of the CBD, but no one is hurt, right? And the critical part is I don't want anyone to be hurt, but I really just want it caught on public view so that we can say, hey, that's not the first time this has happened. It happens a lot, but here's a great example of what happens if you can't do it correctly, right? Because until something like that happens, unfortunately, in Australia, the standards aren't going to be prioritized for 15 kilogram solar weights on buildings. They're
The
just
only
not going to
problem with
prioritize.
that, though, is that the fossil fuel lobby would grab that footage and go, "See, told
Yeah,
you,
look,
don't go
yeah,
to renewables.
But look,
panels will fly off."
Absolutely, but then do you know what else it does? It does the people like Greenwood that are doing site-specific assessments, that are spending that extra money, who aren't profiting and cowboying their way through it, will start gaining some respect for the work that we're doing as well, right? So it's a two-way street. You can come out and then say, we don't allow that, won't happen on our site because this is what we do. We've always done to counteract it. Whereas the people that have don't worry about it, I've got a general certificate, are now they're the ones that are now being questioned on the suitability of their roofs, etc.
Yeah, definitely. I think the first thing I do when I'm on a roof and I'm doing an install, it's been a few months since I've done an install, but who cares about aesthetics? This thing's got to last 25, 30 years. If I've got to run that rail a little bit extra to hit the next purlin, so be it. There's going to be a bit of exposed rail, but ultimately the system's going to be stronger.
Yeah.
I'm not going to have that risk of a panel flying off, and that's the way I go into an install. It's, am I happy with it? Is it going to last 30 years? Who cares about aesthetics? Throw that extra foot in, throw that extra screw in, whatever it takes.
And that's all. I agree. You don't know how much I resonate with that. And just be proud of your work. Like, be proud of your work, knowing that I've put it up there. It's been documented correctly. I've done the structure. The client's safe. I've made the margin, and I've rightfully made for that building, not overused it and whatever else. And I can go back saying that I've got the right insurances in place. I've got the right third-party insurances in place. Everyone's covered. Everyone's happy to keep going. And again, it's just a bloody no-brainer when you're looking at, hundreds of kilowatts and the scheme of the costs. I understand the loss in potential profits because of the stringency of engineering, but know that cost and that stringency is to make sure that you're doing the most professional job possible.
How important is it to come in and do a after install assessment? Like, are people hitting you up to say, hey, we've installed it to your certificate, but can you just come check it for us?
So I'll say two things to that, and it's bloody important, I would say, and especially for the organizations who do a lot of the design work and go through engineering, and then they subcontract the install to another mob. Right? They themselves have done the right thing to make sure all the ducks are aligned and they've got the right ticks and checks. But then at a later stage, we'll go, because they don't have the capacity or because we're closer or whatever else, go do an audit and say, hey guys, they haven't followed our certificate at all. Right? There was a particular year, I think it was 2022. At the end of 2022, I had a couple of graduate students just try, like, getting work experience and whatever else. And I said, we don't have any work for them to actually do right now. So, hey, look at the last 100 projects we've done. They've got addresses. Jump on near maps. And if they're installed in the last 12 months, see if it cross-checks with the certificate. Mate, the surprising result, and I'm just talking aerially. I'm not looking at the clamps and the clips and whatever else. There was like 20-30% of these certificates, they're paid for a certificate. They've just installed it in the wrong zones. Like, it's just like they've just put panels. There's one certificate that we gave, for example, it had so much roof area. It had like 60% of the roof was available. They were only putting 100 kilowatts, but they put the 100 kilowatts only in the section where they weren't meant to put it. So, mate, all you need to do is do this, and it would have been fine, right? Like, so the point I'm making is,
we know why they did it though.
100%.
Electrically, it makes sense.
Just drops the
was
line.
cheaper.
Yeah, man, I get
Ultimately, to be honest, the system's going to perform better.
Yeah.
You're going to have less voltage drop. You're going to be closer to the inverter. It's going to perform better.
Yeah.
But yeah.
But then why get the certificate in the first place?
Yeah, I agree.
Just go ahead and install it, right? That's my point. My point is like, I get it. Just don't waste my time. I don't even care about the $1,000. Just like, just go do it properly. If you're going to do it properly. So then going back to the post install, right? Critical to say, hey, even from an engineer's perspective, I want you to go out there and make sure that what you've provided, your liability and your insurances, are aligned with what we've installed. Because if you've installed something that isn't aligned with the certificate and something goes wrong, we just go and say, why did you do that? That's not aligned with the document we provided you. But when we go out there and say, yes, that is all good, then it's made really, really, really clear. Now, in New Zealand, there's a concept to this. There's a staged PS certification that is governed by the municipalities, where there's a stage where it's called PS4, where they like, it's a part of their design process to get an engineer to go out there and to qualify it. Although it's not technically needed from a permit application perspective, a lot of them are doing it. They're doing it because they just want to make sure that all the dots have been crossed and everything's aligned. And it's things that you guys can do on our behalf. Like, we can give you a checklist that says, check this, check this, check this, check this. And then we can say, yeah, it's going to take an hour of my guy to go through your photos and your information and say, yeah, you're all good. That's exactly what we've said to do.
Yeah.
Are we allowed to get that checklist and supply it to the people who are watching this, who may say,
Absolutely,
hey, I
man.
really want that checklist?
So the checklist here, it's not to say that like this is a checklist that most experienced solar businesses already have.
Yep,
right.
but there's
Like,
a lot
this
of
is
people
just
who are
us.
watching this
Yeah,
who are not.
so I'm encounters
Yeah.
absolutely. This is a thing that you should have at a part of your QA operating process, especially if you're getting younger guys to install and you're just facilitating it. Why not spend few hours just walking through the site and just ticking these things off? Little things like torques of nuts and mid clamps and whatever else. I'm not here to question anyone's due diligence or work ethic, but some people can miss it, or the gun can be set up wrong, or whatever it is. When one mid clamp dislodges, what happens is that panel will flex. It'll only be supported by one side. The next mid clamp's getting double the amount of pressure,
that's it.
and then it just becomes a ripple effect down that array, right? And we've seen it that many times that we're like, it only takes one mid clamp torque to be wrong to get panels flying off a roof, right? So it's a very serious thing, and I would definitely share it with you to encourage you to send it down.
I think it's really, obviously, very important for people doing their own work. Probably doubly important if you're an EPC and you're getting subcontractors to do your work.
Huge.
As part of the work pack, you want them to pick your nose at 10:15 a.m. but not 10:20. I'm being a smart ass, but you know what I mean.
100%.
And we really have to follow this stuff. Now, Tran, like you mentioned before about HVAC on the roof. This is in our little break. Can you expand on that a little bit?
From my perspective, it's just the main reason is a shading issue, but then ultimately I understand that the extra loading on the roof's going to cause havoc as well in terms of engineering. But ultimately we see systems designed and they've maxed out the roof, and then the engineering cert comes in and says, we can't put the panels in the corner zone anymore. Sometimes we have to go closer to those HVAC units even though we don't want to. Is there a downside to that in terms of engineering?
Yeah, so it's a really, really good question. I think HVACs, and let's bottle these in one group. So we're talking about HVAC, any kind of machinery equipment that sits on a roof, any kind of exhaust system that fits on a roof, ventilation system that sits on a roof. It goes back to one of the very first statements I make. What was the building designed for versus how we're using it now? Mm-hmm. Now, if we have a building that was never designed for these loads, and then they've taken these HVAC units and installed them onto this roof after the fact. So the original design engineer hasn't allowed for them, and now they've added it on. They're pretty much going to be using a lot of this allowable load that the building can handle as additional load, right? But if the engineer has designed for these HVAC units, because it's going to be known to be a refrigerated system, roof of extra ceiling loads and whatever else, then there's still loads outside of these considerable loads that we can use for the solar system, right?
Yeah.
So the question comes, when was the HVAC installed compared to the building? If it was originally accounted for, we can still get really good utilization on the roof. If it's after the fact, then it's taking a lot of that load, and it's going to really limit your installation. So when you've had to go close to a HVAC, we would be hopefully double checking and seeing that these loads have been considered in the original design, and we still have the allowable loads around that to be able to give you that guidance and say, yes, go up to it. Alternatively, we say, you can't use this entire rafter, and you've got to go to the next rafter, which is 7 meters away, and you have a big red chunk sitting out of the middle of your installation area, because that whole purlins that are supported by that rafter's overloaded. If that rafter's overloaded, doesn't matter how good your purlins are, your building's already going to be deflecting. So it becomes a nuanced situation. There's unique cases to it. It's not a rule of thumb. But more importantly, if the building's been designed for those types of loads, in its infancy when it was originally designed, then we should technically, according to the standards, have the other considerable loads available for us to complete the assessment.
Just a little bit of a slight variation is we've done the structural engineering report, we're all set to go, right? And 6 months down the track we go to install, and suddenly that building has had HVAC installed on it. Do we have to go and get another structural engineering report and then hit the owner on the head with a whatever because we said, what are you doing? hopefully that's in our contract and it'll be
you'd
a
hope so.
variation.
Hopefully we've got a fine print to cover that one.
That's it, but we would have to do it again, wouldn't we?
Absolutely, and you're going to limit your installation and whatever else. It's kind of first in, best rest. Who's using the loads, right? Because if the panels are on the roof and the HVAC guys wanted to put that, they would have to be, oh shit, why'd you put the panels on the roof? I needed that for the HVAC, right? So it becomes a balancing game on. So it depends on the business, what they need it for, what's more of a priority to them. Typically, if you're putting HVAC units in, there's a mechanical need for it in the premises.
It's going to take precedence.
Yeah, and that's probably going to take precedence over your energy output. So it really comes down to the guessing game, and I hate to say that to solar guys, but you know what I mean, right? It comes down to what the business needs, that your end client's business needs are. So yeah, but you're 100% right. The loads are. It's a pain because you can
Not to mention it changes our financial proposition because suddenly they whack these multiple 20 HVAC systems on this 200 by 100 metre roof, and we didn't take into account. So that's where, for anyone out there, make sure you've got your contract very fine-tuned and variations.
I think the other thing I'd raise talking about if a HVAC did get installed after the fact and then we've got to go in is I've definitely been on roofs when I've read the engineering cert and it's stipulated Purlin spacing to be 1400, but I've got up there and went, nah, guys, no way. This is only 1200 spacing.
Yeah.
Well, should say it the other way around. We're going
1200,
bigger. 1200 going to 1400.
Yeah.
100%. First red flag is, hey, this cert's no longer relevant. You know,
Absolutely.
if we're going from 14 to 12, well, clearly we're stronger. We're going to be okay. We're still relevant. But if you're going from 12 to 14, again, we've got to come back to you guys and say, hey, look, actually there was a mistake done in the original assessment from whoever's done the building assessment. Not saying Gamcorp goes out because we often can do it ourselves. And we'll measure the Purlin spacing and the mistake's been made, but nonetheless not pointing fingers, but it's just got to get recertified.
What's really common, Trent, is when buildings are designed, like we've talked about corner zones and what we're talking about before about we check against how buildings were designed, right? So if a building was designed for a wind pressure in the corner, it would have Purlin spacings every, let's say, 800. But as it goes to more less wind pressure areas, it would be further spaced apart because there's less wind pressure to account for and the roof sheet can handle it and whatever else. So what we find happens a lot is that someone goes and measures the edge of the building because it's the shortest bit and they're like, oh yeah, Purlin's at 1200. But then they don't realise that when it gets closer to the centre of the building, it goes from 1200 to 1400.
Yes,
1200
yes.
to
Yeah,
1600.
super valid point.
And that might be okay. That might be okay in the sense that 1600 still might be okay, but it's got that extra spacing because of the lack of wind pressure. So what we say now is when you're doing inspections, don't do one point. Check the centre, check an edge, and check a corner. Because the best chance of getting full utilisation is actually knowing what the building's done to accommodate for these different wind pressures. In the days, they would say, what's the most critical wind? And then because of building material and labour wasn't as critical, they would just install the whole roof with the most critical Purlin. With the most critical
I was going to
spacing.
ask that. Yeah, right.
But now, builders are like, mate, I need to save every bloody cent. And guess what's one of the most expensive parts of a warehouse? It's the bloody roof. There's so much steel, there's so much sheeting, there's so much labour, so much risk, high-risk work. So because of that, it's so expensive that they're like, engineers, we've learnt over time, I'm talking about builders here, engineers, we've learned over time, there's less wind pressure there, give me different Purlins there, give me different Purlins there, give me different Purlins there. And they've got down to the fine tooth. Now, just to add, I know your follow-up question's about to be, these buildings are designed so lean now as well, for that same reason, right? So the amount of additional load that we can put is even less because they've been designed, they've been pressured by builders and the like. I shouldn't say builders aren't just developers, whoever, from a cost perspective to get it so accurate. And we can do that now because we have softwares like Space Scouts and whatever else. We can do a global analysis and we can model the entire thing on the computer and apply these very accurate sizes to accommodate for cost savings, which is a really beautiful thing. Like it's a testament to technology, it's a testament to the evolution of engineering, but now we want to use that thing to do something else with it. Was it designed for it? Was it allowed for it? And then that discussion comes in. And then we have engineers, God bless them, and there's nothing wrong with them, and I respect the work they do, but they say, we've allowed this area for an extra 15 kilograms of weight for solar. And they put that area in the bloody corner zone. Do you know what I mean? It's like, mate, like, thanks. Like, I appreciate the extra weight. Like, it does help. Like, but... Mate, do you know that they're going to have to do 4 rails or like they can't even install there because of the high wind of the racking or it's a clip lock roof?
Has it really been 4 rail systems? Really? 4 rails?
we've seen 5, 6 rail systems. If they're desperate enough, really, they'll do it, mate. They'll do it.
Poor installers.
But hear me out, right? Like, this is where a building designer will do the most beautiful building, and then they chuck a really shitty long line on top of it, or a clip lock on top, a weak clip lock on top of it, because they're saving them a few bucks because that clip lock guy's got a cheaper clip. But what does that mean for anyone else trying to use that sheet after the fact? Right now, we have to have the extra rails. We have to, because it's not our fault. It's just the wrong sheeting was used. But the engineer doesn't even pick the sheeting because it's not an engineering thing. It's an architect thing. So the builder picks it based on his relationship with the roof sheet guy down the road. Like it really comes down to, it's so much. The building design is so much bigger than solar, right? It's so much more expensive than solar. So the considerations for its use is like, we've allowed for 15 kilograms of dead load, which is great. I'm not downplaying it, but chuck it in the internal region to give the solar guys the best chance.
The
best chance to do it lean and do it properly.
They've not installed a 5-rail system before, that's for sure.
Yeah, exactly.
It's a challenge.
Mate, physically, how do you actually physically fit it in there is half the problem. But yeah, no, I hear you loud and clear. Does that answer the question?
It does.
It does. I'm sorry.
No apologies.
He's hearing 5 rails and he's losing more hair. I'm sorry, mate.
He's seeing the dollar figures. He's going, geez, that's an expensive panel.
Why do you think I lost all my hair, mate? Because I talk about this every day.
There's a few main things here. Obviously, safety comes first, and no engineering company's going out of their way to make it difficult for an installer. Just trying to show this is what we do, this is why we do it, right? And this is what you need to take into consideration when you are looking at these roofs. The question I want to ask is, do you expect or appreciate or even want the installer whoever's inspecting the roof to actually check the thickness of the purlins?
Absolutely. So one of the trainings.
So they have to take the sheet up and to do that, though, don't they?
Or they get this is lift and go underneath it, which is what
True.
we do, right? Because we don't lift sheets. But every time our guy goes out there, our guys or our trained contractors who are engineers and building inspectors around Australia and New Zealand, they've physically got a micrometer or a digital caliper, and they're measuring the thickness. And the thing I like to say is, if I've got a purlin that's 200 deep, right? It's a 200 deep purlin, whether it's Z or C, it's irrelevant, and it's 1 mil thick. It has a certain capacity, and it's allowed to span a certain distance. If it's 1.5, that's 50% more steel in that purlin. If it's 2.5, that's 2.5 times stronger than that other purlin. So if you're looking at it and saying like, yeah, it's a C200, assume 1.5. If it's 1, we're in trouble. And if it's 2.5, you could have had the whole roof installed, but you just assumed 1.5.
Just because you didn't measure it.
Just because you didn't get a caliper out, right?
You've got to take worst case scenario though. You've got to assume.
So we don't always take worst case. If we're going to make an assumption, what we do is we say, because of its span and its spacing, it should be 1.5, but it could be 2. But it should be. We're not going to take 0.75, which is the worst case, which is the least available on the market.
Wouldn't that information be on the plans, though?
Absolutely. So if you have plans, don't even go out on site. Just give
no
me the plans. But if you have
we have to go outside anyway to look at the electrical infrastructure.
But the point I'm making is that if you're doing an inspection for a structural engineer, not getting the thickness is like, in my opinion, it's like giving me all the information of a car, but not giving me the tires. Like, I need to know that one thing that's critical for this thing to move. Like,
why is it so critical? Are we talking penetrative fixing or non-penetrative?
So for penetrative fixing, it's critical for the fixing because it, depending on the thickness of steel, the capacity between the screw and the purlin's thickness is critical. For non-penetrative fixing, it's about the deflection of the purlin.
So it still does come into play, because in my mind I'm thinking purely for penetrative. The thicker it is, the stronger it's going to be. But it's still non-penetrative as well.
Absolutely. I like to say if I have 1 spaghetti or if I have 50 spaghettis, how much harder it is to break. That's all I'm doing is change the thickness. It's the same material. I'm just changing how many of them there are for us to be able to break it. It's critical. Again, knowing it's like saying the difference between a 200 and a 1. I'll take a 200 at 1 mil. I'll take a 150 deep C purlin at 2.4 mil thickness over a 200 purlin that's 1.5 mil thickness.
You love those hardwood purlins too.
Right. If it's hardwood versus, I'll take a good hardwood timber purlin. Gives me great fixing capacity. Gives me, it depends on what it is, but don't give me a top hat that's got 0.4 bloody mil thickness, because then I can't get any fixing, and the bloody thing bounces like nothing. So for us, it's a no-brainer. If you don't have a thickness, we have to make an assumption. The assumption is not going to be good. Get the thickness, you get the best results possible. That's our whole spiel.
You brought up top hat 0.4. I can't believe it. Like, I can't believe there's certificates that's come out that do allow us to fix onto that top hat. It's crazy. Like,
it's bloody crazy, mate. They're thinner than roof sheets, right?
Yeah.
So top hats, from my understanding, there was a period of time in the economy where timber shortage was a problem and the cost of timber was really high. And innovatively, the roof sheet manufacturers have come up with top hats, which are a great concept. And listen to the perfect application for it. The perfect application for it is you've got timber truss residential building, okay, and you want to put sheeting, but you can't put sheeting on the trusses. So you have to have something else to connect to.
Yeah.
All this thing does is allow you to connect to the to the timber truss. That's what it's doing. It's using another piece of small sheeting, which is a top hat. It's a very small folded sheet. And it's just distributing that load case from your foot to the truss. Really great use. But now we have commercial little sheds or carports, and they're built out of top hats. They're not designed for this type of build. And even if they are, and you can make them work, the fixing capacity is shit all for your solar system. So you got to. Does that make
That's
sense?
the technical term that structural.
Yeah, shit all. Yeah, and that's the problem. And then we say we need the same thing. We need 4 rails. I don't need 4 rails. I just need more fixing. And the only way I can get more fixing is by putting a rail with 2 feet under it to get more L feet in, or whatever foot in, to get the fixing capacity I need. So the whole point is we don't have fun giving more rails, or we don't want that. That's the last thing we want. But when we're left to make scraps like this work, like top hats, and you're right, I can't believe it's still being commonly used. We have no choice. We've got no choice.
It's all the new builds. They're just coming out day in, day out, top hat design, and then these resi boys are going in to install on it, and they've just got to go more fixings. It's the only solution.
Yeah, and it's again, remember this: the cost to build that thing was a lot more important than the cost of how much the extra rail is for the builder and for the asset owner, right? So if you go, but my counter statement to that is it's not that big of a difference between top hats and timber battens, right? There's not that big of a difference in cost. But when you're buying the roof sheet these days, when you're buying sheets from the roof sheet manufacturers, they will bundle in. They'll bundle in the top hat prices. So for them, it's like they're not even choosing to go timber or not go timber. They've got the truss designed by an engineer. They send it to a roof sheet manufacturer. They send them everything they need to put the roof sheet on. So I don't blame them, but at the same time, again, anyone after the fact wants to use that, and they've got to deal with this, which is the hard part.
Yeah, it's tough.
Very tough. Very tough.
Any final points or final questions, or just final statements?
I think we're talking 3 rails, 4 rail systems, perpendicular, parallel. I think what also comes into play is the clamping zone of the panel. We haven't really touched on that. So, the reason we want to go perpendicular to those purlins is we get a huge amount of flexibility in that roof design, and we can hit the clamp zone that we need to for the panel. So, one thing's talking about going parallel with the purlin. Awesome, we can put in more fixings, but often those purlins don't line up with the clamp zone of the panel.
Correct.
So then you end up with these. Not boomerang. Could be a boomerang. Diving board. Diving board.
Yes.
Versus if you can go that perpendicular setup, you just structurally it's huge.
Yeah, and it's a huge one. So know that the panel manufacturers are doing a lot of testing and a lot of work to make sure their panels are good and suitable. So they have to pass leaps and bounds of testing and cyclone tests and whatever else to make sure that they can reach certain KPA pressures so that you can use them across Australia. And then the good panel manufacturers, and that's most of them these days, do extra tests to say, okay, if you can't put it in these exact ideal locations, for less wind regions, you can put it in these regions, for example, in other regions of the panel. And they provide that really good guidance, but understand the cost that's involved for them to do that is bloody significant. So when you see that, appreciate that. Anyway, I'm not going to mention companies specifically, but one that we recently worked with, they're doing so much so that we can say, you have that flexibility. Yeah, you can use this, but use this panel, because this panel will be able to get your desired outcome because of the flexibility of the claim.
Yeah, but that panel might be 5 cents a watt more expensive.
Correct. But
this is the thing. So if
the question is no panels or a panel with 5 cents more expensive, what's the answer?
Right? Yeah, well, gotcha.
So then that's what I'm saying. Not to say that its application is best used against every site, but there's sometimes where we've got lightweight panels that are made out of flex, right? As much as I love the product and its adhesive ability and whatever else, it's got an amazing use case where it's no panels or that panel.
Yeah, right. And
if that's your two options, then who cares, like, with respect to the cost, but who cares about the cost, because it's unlocking this area that was once not suitable.
The thing is, right, definitely from a design perspective, you're only restricted when you run your rail perpendicular in regards to clamping zones. You're restricted by the 233.3 millimetres between peak of the roof sheet, which is a heck of a lot better than the fact that it could be 1.2, 1.4, 1.6 between the purlins if you're running it that way. Yeah, so but I mean, we have to follow what we follow, and again, like AS3000 says, follow the manufacturer's guidelines with stuff, and with the panels we have to. And if they don't fit, well, maybe that's when you do look at another fatter or longer or whatever panel to fit. It's a hard one.
The other one with parallel, the other nitty tricky one with parallel is also that let's say the purlin spacings are whatever they are, 1.2. If you're following Gamcorp's methodology of having to be on purlin, or whether it's screw or clamping on purlin, then you tend to have a gap between your rows as well. So not only is the mid clamp an issue, but you're going to have these two rails on the purlin with a bit of an overhang, and then you're going to have to use the next two purlins. Because you're going to have to use the next two purlins, the gap between the panels might be 800 mil or 600 mil. So you have rows of gap of unutilized roof area. If you switched it around, you'd fill it up completely, right? Other than walkways and whatever else. So the point is that it's that element of it as well, but more importantly, we can make the mid clamps work with most purlin spacings. It just in certain zones and whatever else. But it's the other way that gives you that maximum flexibility. But what I will say is one thing, and it's one thing to know, is a lot of people don't even understand the consideration of pressure on panels. Know that as panels get bigger, what we're doing by adding rails is a new element. We're adding a rail to distribute that pressure again. Because we're looking at buildings that are designed for a per 1 square meter load. Now you've got a 2.39 panel by 1.3 wide or 1.18 wide. That's more than 2.5 pressure on that panel over 2 square meters, right? So we need to add rails to help like redistribute that, but also for the panel to not be able to. Was it diving board? Diving board its way through a wind.
And this leads on to a discussion probably for another time of the whole thing of how big do you allow the panels to be on a roof. Ground mount different, but there's a certain size taken into consideration. 2-man lifts, diving board effect, panel clamping zones. How big do these panels going to bloody get?
The solar industry is the problem. They still buy them. It's like solar installers like big panels as well. Like I don't get it. It's like there's plenty of panels on the market that are available that are market like at a good price. That do a good job. It's safer for you guys. It's this. It's that. It's all these things, and it's better for the building structure from my like very niche little part of it. But you see a new panel, it's like, oh, did you see that guy brought out a 2.3 meter? And, oh, we're going to get that. It's like, mate, that's for ground mount. It's made for that. It's really great for those systems. It's not for your roof, and it's not for your guys that are, suspended and anchored and whatever else. So my whole point is, if the industry doesn't encourage it and buy it and go for it, and they use good, nice 2 square meter size approximately panels, then you're going to see a lot better installation. You're going to see less rails, and you're going to naturally see the solar panel manufacturers saying there's a demand for that.
Well, it's incumbent on the designer to do their analysis and go, hey, these are the ideal size of panels. We maintain a one-person lift. Yes, there's more panels to put on for a system. But you know something? We're actually saving 10, 15 grand because of the labour. It's not a two-person lift. People are not getting fatigued. People are not leaving the job because they've been, they're tired out and all of that other stuff. And that's what you've got to do. But we're right at the end. Final final sort of statement, Sanna, on this, the whole kit and caboodle?
Oh man, if I was to say anything as a final statement, it would be kind of going back to what we like the way I closed it and mentioned here is like, as solar installers, focus on your specialty, focus on your expertise, focus on what you guys need to do best, and get support from industry, whatever industry, whether it's structural or panel manufacturers or whatever it is, to say, hey, I'm going to lean on them for a very small portion of cost in the scheme of the installation to make sure that my books are done right and that I don't hold liability or I don't hold responsibility. It's in the scheme of a business. I just don't understand how certain businesses do it without it, or go to people that say dead load's all good, because it's just, to me, it's not a right business decision. But every business is different, every person's different. My strong encouragement is, as you're going into commercial from resi, know that these implications are needed, these steps are needed, and as you're going from commercial to bloody heavy 1 megawatt commercial, whatever else, it's a bloody no-brainer at that point. So that's just my spiel as a summary. But again,
Good
really
advice.
appreciate Greenwood, really appreciate you guys not only wanting this for yourselves that you have historically, but also showing the need to share it with the industry. It's very admirable.
Trent, any last words?
No, I think we've covered off a huge amount of topics, and it was great to have you in and be able to get down to the nitty gritty of all of it. And I think just taking away that clip lock on Purlin, the strength onto the clamp is one of my takeaways I'm going to take from today.
Awesome.
That's great. All right, well, thanks very much, guys. Thanks, Sanna, for coming
Pleasure.
in, and thanks, Trent, from coming down from your desk down to here. It's been really good. I've learnt, and hopefully the people watching this have learnt. And for those who are watching, don't forget to like, comment, and subscribe. All that stuff. Hit that button. Thanks very much.